Okay, hello again, Falcons. I hope everybody's doing okay. So for today's video, I'm just going to go over a couple of the two homework proofs I had you do, and then a couple more, and then I'll have you do 3 for yourself, and then hopefully I will be back on Thursday. Okay, so in proof number 2 that you guys tried, it says that those two pieces of given information, they're marked in the diagram, but then it tells us to try to prove that this line BD is equal to BG. So if either set of these little triangles is congruent, those would be equal to each other because of CPCTC. So that would be our goal, to try to get those two shaded triangles. You could do this pair or the other pair, and it would do the trick. With the given information, though, something's flashing at me. What's flashing is that these two vertical angles, angle ABF is congruent to angle EBC. The reason is because vertical angles are equal. And once I mark that, I can see that triangle ABF is congruent to triangle EBC because of side angle side. Now, why is that useful? Well, because if I know that the two big triangles are congruent, the rest of their corresponding parts are congruent. So that means that angle A is equal to angle E because of CPCTC. So I can mark that angle equal to this angle. And then we have this side equal to this side. So then I'm going to put a little 1 here and a little 2 right here. Angle 1 would be equal to angle 2 because those are vertical angles as well. Vertical angles are equal. Then once you mark that, we can see that triangle, triangle ABG is congruent to triangle EBD because of angle side angle. And now that those triangles are congruent, we see that BG is equal to BD. And you can tell that I assigned my triangles correctly, and it's because of CPCTC. Okay, number 3 that I asked you to do, with all of this given information, they want us to prove that these two outside triangles are congruent. So if I just simply say, look at the given information here, we can put a right angle there. Don't need to put anything into our proof. But I can say that PS is equal to PS by reflexive. Then once I mark that, I can see that those two inside triangles, triangle TSP is congruent to triangle RSP because of side angle side. Now, once we have those two triangles congruent, I think, what can I use from those two triangles to help me prove those two outside shaded ones are congruent? Well, how about TP and RP? TP, whoops, that should be a P. TP is equal to RP because of CPCTC. Okay, remember that's a P. And then now, do you see that congruence pattern with triangle PTU congruent to triangle PTU, PRQ by side angle side? I know these are not easy, but they really do fall into place, like I've said before on occasion. Okay, number 4. I'm going to do 4 and 5 with you, maybe 4, 5, and 6, and then I'll ask you to do the last 3. Okay, given information, what do they want us to prove? So they tell us that V is the midpoint, so I know how to use that. They give us parallel lines, so I'm going to be able to use that, probably for alternate interior angles. And then they want me to prove that, let's see, what do they want me to prove? They want me to prove that this line is equal to this line. So if I can prove that these two triangles, if I can prove this triangle congruent to the other shaded triangle, then I'll have WV and YV equal to each other by CPCTC. So let's use the information in order. V is the midpoint of XZ. So that means that ZV is equal to VX by definition of midpoint. So I'll mark that. Boom, boom. I have vertical angles. I'll put a 1 and a 2. Oh, I guess I didn't have to do that. Well, let me use the parallel lines. I'll go in order like I'm supposed to. Since XY is parallel to WZ, I know that angle 3 equals angle 4 because alternate interior angles of parallel lines are equal. And I actually have more information here than I need because I could use both pairs of alternate interior angles. But I'm going to go ahead and use angle 1 equals angle 2 because vertical angles are equal. And can you see the congruence pattern now? So triangle WVZ is congruent to triangle, let's see, if I say WVZ, I gotta say YVX, and it's gonna be angle, angle, side. And now that the triangles are congruent, we have YV and WV are equal to each other. So WV equals YV by CPCTC. And I suppose we could say YV equals WV. Do you remember what property that's called? That flip-flop is the symmetric property. We're probably at the point though where we could skip that step number 7. Number 6. Okay, what are we asked to do in number 6? We're asked to prove that KL is equal to LM or ML. Well, if these two triangles are congruent, wouldn't you agree that those pieces would be equal? So they tell us that angle 1 and angle 2 are equal. And then they tell us that angle 4 and angle 5 are congruent. Well, I almost see an angle side angle going on there. Angle 1 is equal to angle 3. Why is angle 1 equal to angle 3? Because vertical angles are equal. And then if 2 equals 1 and 1 equals 3, we can say that angle 2 equals 3 by substitution or transitive. I like the transitive here. Remember, transitive says if A equals B and B equals C, then A is equal to C. So can you see how that works here? A equals B, B equals C, therefore A equals C. So now we have this pair of angles equal, this pair of angles equal. I can say that JL equals JL by reflexive. And then can I stop there? Well, I'm almost done. So I can say triangle JKL is congruent to triangle JML by the angle side angle for congruent triangles. And then we have done what we wanted to do. I can now say that KL is congruent to ML by CPCTC. So that one wasn't too bad. And then the last one. Okay, this one, I gotta try to watch my time. Okay, so we want to prove that RU is equal to SU. So if I can prove that this triangle is congruent to this, then I will have it. They give me angle R equals angle S, and angle 2 is equal to angle 3. Well, if I can prove that triangle RTV is congruent to triangle SVT, I have vertical angles here at 5 and 6. If I can prove that the two big overlapping triangles are congruent, I'll be able to say that RT is equal to SV by CPCTC. And then I'll have those two triangles congruent, which would give me those two pieces congruent. So kind of thinking and making a plan. So how am I going to get those two big guys congruent? I see that they share TV, so I can say that TV is equal to TV by reflexive. Then they have, oh, we have it. We have an angle, and a side. An angle, and a side. So I'm good to go just with that one thing. I was thinking we might have to use the third angle theorem, but we don't. So do you see again, I have angle S, angle 2, and TV. I have angle R, angle 3, and TV. So triangle RTV is congruent to triangle SVT by angle, side. Then the next step would be, okay, why did I want to prove those congruent? Because now I can say that RT is equal to SV by CPCTC, and then boop, angle 5 and angle 6 are equal because vertical angles are equal, right? And once we mark that, can we see a congruence pattern now in those two shaded triangles? Well, I hope you can see that triangle RUT is congruent to triangle SUV because of angle, side. So look at how far we've come, you guys. So RU now is equal to SU because of CPCTC. Now I know these are tough, but I think if we walk through them, hopefully they make sense. Okay, I want you guys to try 7, 8, and 9. Now I know you can do a lot of the proof. You might not be able to complete it all the way, but you can do quite a bit of it. So good luck, and I hope I see you tomorrow and we can go over these in class. Okay, have a great day.